You ever look at your super smartwatch or your earbuds and wonder why the battery life is, well, just terrible? It seems like the smarter our devices get, the faster they die. Well, a huge breakthrough in chip design might finally have a fix. Today, we're going to look at some amazing new tech that teaches AI chips not just how to think better, but how to talk a whole lot smarter.
It's this weird paradox we're all living with, right? We want our gadgets to be geniuses, but we also want them to be tiny and to last for days, not hours. And that sets up this massive tug-of-war for engineers. It's really the central problem we're going to unpack in this explainer.
Okay, so let's dive right into this challenge. We're calling it the smart device paradox, and it's pretty simple. The goal of making our tech incredibly intelligent is basically at war with the goal of making its battery last.
I mean, this really says it all. We expect to have the power of a supercomputer inside a device the size of a postage stamp. The problem is, that kind of high-level AI thinking is an absolute power hawk. It takes a ton of energy to process information and send it around, and that just murders batteries. It's a huge headache for anyone trying to build the next cool piece of tech.
So if we're going to solve this, we first have to understand what's causing the problem. So let's meet the two main culprits, the technical issues that are just sucking the life out of our smart devices.
All right, on the one hand, we have something called the memory wall. In the engineering world, they call it the von Neumann bottleneck. Basically, think of your device's chip having a brain, the processor, and a library, the memory. They're in two different places, and the chip wastes most of its energy just physically moving data back and forth between them. It's like you having to run to the library for every single thought. It's exhausting. Then, on the other hand, you've got the wireless tax. Your device's radio, it's basically a dumb pipe. It has no idea if you have a great signal or a terrible one. It just blasts out the data regardless, wasting tons of power when that signal is weak or noisy.
The whole process works like a really clumsy relay race. First, the sensor grabs some data. That's the first runner. It hands the baton to the processor, which does some math. Then, the processor hands another baton to the radio to send the info out. Each of these handoffs is totally separate. The components don't talk to each other, and energy gets wasted at every single step.
So how in the world do you fix that mess? Well, the first part of the solution is a completely radical new way of computing. It's one that actually copies the most efficient computer on the planet, the human brain.
It's called in-memory computing, or IMC. And instead of having that separate brain and library, IMC does the calculations right inside the memory chip itself. Imagine if the books in your library could just magically update themselves with new information without you having to carry them anywhere. By doing the thinking right where the data already lives, it just completely demolishes that energy-wasting memory wall. Now, this is the really crucial thing to get. The massive win here isn't about making the processor faster. It's about making the data travel less. A lot less. You know, in our brains, the neurons that process and the synapses that store are all tangled up together, which is why it's so efficient. Well, in-memory computing finally brings that exact same idea to a silicon chip.
But okay, that only solves one part of the problem, right? The internal part. Now we get to the second breakthrough. And honestly, this is the most revolutionary bit. Making the AI chip itself aware of the airwaves all around it.
So let's go back to that clunky relay race. In the old way of doing things, the wireless radio is just a separate, clueless part. The AI has no idea what the signal quality is like, and the radio has no idea what the AI is trying to accomplish. It's just that dumb pipe blindly pushing data out into the world. But in this new system, this is where it gets so cool. The radio becomes an actual thinking part of the AI's brain. Researchers at Nanjing University basically taught the AI to listen to the wireless channel. The signal strength, the noise, all of it. They made it a learnable, trainable part of the neural network. So now the AI doesn't just process information, it learns the absolute best way to send it. This quote from the researchers just nails it. The AI now understands its own environment. So if the wireless signal is weak or super noisy, it learns to automatically compress the data, or just send the absolute most important bits to make sure the message gets through. But if the signal is perfect and crystal clear, it can send way more detail for better accuracy. It's this dynamic, smart relationship.
Okay, this all sounds fantastic in theory, but the real question is, does it actually work in the real world? Let's take a look at the results, because this shows it's not just an idea, it's a huge success.
So, they put the prototype chip through a standard AI test, recognizing house numbers and pictures, and it achieved an incredible 93.71% accuracy.
Now that number is right up there competing with conventional power-hungry digital systems. But here's the thing. It did it using a tiny fraction of the energy.
But here's the part that really blew me away. The system didn't just fall apart when the signal got bad. Because the AI was trained to expect and understand the messiness of a wireless connection, it kept its high accuracy even when the data was low quality or getting interrupted. It literally learns how to fill in the blanks because it knows which bits of info are critical and which it can afford to lose to save power.
So yeah, this is way more than just a cool lab experiment. Let's zoom out and talk about what this tech actually means for all of us, because it could change pretty much everything about our connected world.
This one breakthrough unlocks so many new possibilities. I mean, think about the Internet of Bodies, medical implants like glucose monitors that could run for years instead of months because they only transmit critical alerts. Imagine swarms of drones that can coordinate in a disaster area even when the signal is awful. This is the kind of hardware that makes the futuristic native AI of 6G networks actually possible. It lets you build smart cities with thousands of sensors that don't crash the whole system.
So, at the end of the day, the big takeaway is this. For the first time ever, we've basically erased the boundaries between a device's memory, its brain, and its voice. We've built a chip where thinking and talking are all part of the same seamless process. That's a fundamental shift, and it leaves us with one really exciting question to think about. Now that our devices have learned to truly think and talk together, what incredible things are they going to do next?